Hi everyone, my name's James. I'm an engineer here at NI. Welcome to part 2 of how to add FPGA-based custom I/O into your NI VeriStand project. In part 1, I prepared my LabVIEW FPGA code for use with the FPGA Addon custom device for VeriStand, and I compiled that into a bit file. In this second part, we'll import that bit file into VeriStand via the custom device. Let's have a quick refresh on the code that I compiled. So it's here, we've got 3 different loops where we have a pass-through, which will go straight from input to output. We also have an increment, which adds +1. Then in the bottom loop, we have an analog input from one of our modules. And in the far right loop, we have an output where if I set an enable to true, it will take an offset and add a value. Or if the enable is disabled, it will be 0 volts that is outputted. That's our code. It was compiled into a bit file, which is here at this directory called FPGA custom. And that's what we need for our FPGA custom device in VeriStand. So let's get going and add that into VeriStand. I've made this project based on the default project template and configured my target, which is the Compact Rio. Let's go and add the FPGA custom device. So if we click Configure, expand out Controller, select Custom Devices, right-click NI FPGA Addon. This will add the FPGA Addon custom device. We want a new instance of this, and it takes us to this page. In the options here, if you click on the Open folder, we select the path to our bit file. When I click OK, it will then look through that and it will work out what the inputs and outputs are from that bit file, or like the code inside. We also just need to check that the Rio device matches the one that we want to deploy to if you had multiple FPGAs in your system, for example. So if we go to Hardware Configuration Utility, I can see my Compact Rio controller here, the 9049. And Rio 0 is my FPGA target. Perfect. I've connected the voltage input and output modules here on channel 0 to each other. These are also in FPGA mode as a quick refresher that we need to do that to make it work with Compact Rio. If we expand that out, we now have these scalar and waveform groups. Scalar, this is for controls and indicators on our FPGA code. So you'll see here, these are my indicators. Now, when we say inputs here, these are inputs into VeriStand from our bit file, our FPGA. So these are my outputs from the FPGA itself. I can either select one at a time and click Add Selected, or we can use Shift and just select all of them to add them in one go. I'll do the same for the outputs here. Select them all, Add Selected, and they're now in my signal tree in VeriStand. For waveforms, it's the same workflow, and these are through FIFOs in our project. I just didn't have any in my FPGA bit file. Great, we're good to go. We'll save that, and we can now deploy. So we can deploy that. We'll switch to a UI and place down some of our channels. So I can expand these out and we can drop these down onto the UI. And then we just wait for that to deploy. So if we use the increment, for example, and put this up, you'll see it's always one ahead. The pass-through, it matches. And our offset here, well, we're getting nothing out, but that's because I haven't enabled it yet. We click Enable, and we get the value that we need. Obviously, this is moving up and down. It's a real-world signal, so we're capturing one data point here with what we're getting. Maybe you could add down a chart for something like that. and I want an input, and that will display your voltage channel, for example. Great, so that's how we add FPGA I/O into VeriStand using the FPGA Addon custom device from NI. For more information, don't forget to visit ni.com/VeriStand or visit our GitHub page for the custom device, quick start guide, and more information and examples that I showed you in part 1. Thanks very much. Thanks for watching.